Hello, welcome. I'm Buff López, an associate in materials and chemicals at Cleantech Group. Today, I'm joined by CEO of Ardent Technologies, Erica Nemser, to talk about point source carbon capture from industrial emitters. So Erica, thank you for joining us. I'd like to start off by painting a big picture in talking about the economics of carbon capture and why point source capture makes sense over other abatement solutions.
Sure. Thanks for having me, Buff. I'm really pleased to be here. If we take a look at point source carbon capture and how it fits into the ecosystem of energy transition and decarbonization, one of the first things that we see is there are kind of three big sources of CO2 emissions in the world. There's energy, and there are great decarbonized solutions. We all see solar and wind. There's transportation, and again, that's been electrified, and we see that on a fantastic pathway. When we look at industrial sectors, whether they're making energy or they're making materials, things like cement, things like steel, things like the chemicals that we use in products every day, those don't have an easy solution. They're the so-called hard to abate sectors. And for many of them, it's not just that they're releasing CO2 through combustion, like flue gas and other industries where you're burning fuel for the heat or energy, but they actually release it as a part of their processes. And so really moving them on a decarbonization pathway is finding a way to have those industries still produce the materials and energy we need and capturing the CO2 out of those, whether it's cement or steel or otherwise. Point source carbon capture makes a lot of sense because that's high concentration CO2. So it's less expensive and more efficient to capture that CO2 directly from those emissions processes versus waiting until it's in the air and then trying to capture it.
Okay. So we've heard from industry for years about the need for low energy membranes. And of course, Ardent's composite membranes are able to achieve this using just chemistry and no pressure, right? Can you tell us a little bit more about that breakthrough and what it means for industry?
Sure, thank you for that tip. We use a little bit of pressure, but that's true. But you described exactly the innovation, which is when you look at CO2 capture, we're capturing a product that people don't want in the air and they don't really want. It doesn't have a lot of value. And so the question that's posed to anyone in industry trying to deliver a valuable solution to customers is, how do you make that as inexpensive as possible? And if you look at the big expense, it's a little bit in membranes or solvents or whatever system that someone would use, but a lot of that is in what we call the balance of plant. It's the compressors to run it, it's the steel that surrounds it as a system. And so what we deliver is the solution to that problem of how do you make that as small as possible? Because you don't want a giant plant that's doing carbon capture because it won't fit in an industrial facility, and you don't want the expense of it. So the innovation of our membrane is something that can work in a very small, compact system. So it's inexpensive from a capital standpoint of what you have to put together, and it runs at very low pressure. So we don't need a lot of expensive things like compressors, et cetera, that can be both expensive to purchase from a capital standpoint, but also expensive to run. And so this is a perfect marriage between membrane technology that likes to operate in a humid environment and likes to operate at low pressure with the actual needs of industry, which are they produce a lot of flue gas that's full of CO2, it's at atmospheric pressure, and it's full of humidity. And so because our materials love that and do very well in that environment and enable us to create a system that's less expensive, we're cost effective from the get-go, and that's very important to folks in the industrial space who are looking for carbon capture solutions. Customers are very oriented to easy to use and practicality, like all of us are in anything that we purchase. And for them, it's about being low cost and inexpensive, but also being something that's small, can fit in their plant, something that can handle all of the poisons and not need a lot of pretreatment, not need a lot of complexity. So our customers tend to look at this as simple as a filter cartridge that you have in your air conditioning at home. They want something that easy to use, and that's what we deliver.
And so why is that modularity important to your customer base?
So modularity is really important to the customer base for a couple reasons. One is that scalability down. So a lot of industry is driven off of really large installations, right? That we get cost effectiveness out of scale. But if you look at where CO2 emissions come from, there's thousands and thousands and thousands of smaller emission sources across industry. Things that are like the boiler that you have in your home if you have one for home heating, right? Just slightly larger versions of that. They are not industrial size emissions of millions of tons of CO2. And so having something that's modular and scalable and that can work at those smaller scales enables us to address the vast majority of the streams of CO2 that are currently getting emitted from industrial sources. The small ones, the medium ones, the large ones.
This is interesting because we hear a lot of rumblings about direct air capture, for example, being a great solution because it can be deployed on large scale, but it's widely thought to be years, possibly decades away from deploying at large scale. Then we think about all of these emitters that are mid-scale, maybe 100,000 tons per year or so, and they're kind of getting left behind. They don't have hundreds of millions of dollars to invest in capital. So a solution like yours opens up the door for these types of emitters to engage, right?
Absolutely. And so we really do look at some of those smaller and mid-sized emitters as important players in the ecosystem of CO2 capture and really valuable customer base because they are at the vanguard of being able to adopt a new technology and do so in a variety of different business models. Everyone talks about deploying that capital, and some customers will purchase systems, other customers look at carbon capture as a service. And so some of those mid-sized customers are the ideal type of customer for that. They look at CO2 the way they look at other utilities, right? They want to treat CO2 the way they do trash pickup, right? That they pay someone on a per ton basis to take their waste away and they don't have to think about it. And addressing that market is really important.
So what are some of the bottlenecks of maybe the more leading solutions, like with amines, for example? I know that a lot of incumbents are kind of focused in this area. What are some things that you're able to achieve with membranes that amines aren't?
Sure. So amines are a commercial solution now. They're used across the industrial landscape at very, very large scale. So if you want to capture 1 million tons of CO2 per year and you have an ability to handle the chemical toxicity profile of amines, which is mainly limited to anyone in the petrochemical chain right now, that's a great solution. Two big challenges to amines right now. One is the efficiency of scale. They are not going to easily scale down to some of these cost effectively to some of these smaller applications, and their utility and chemical profile are not applicable. You would never put an amine plant, for example, in some of the places where we have sort of cement kiln customers, that they're across the street from a neighborhood. That's not an appealing prospect. They don't have the utilities there to even support that kind of plant. So again, membranes that are as simple and easy to use as a filter cartridge that just need to be changed out every 5 years or so is a very appealing prospect to a bunch of customers from the standpoint of the size and economies of scale at those smaller scales that you can do with membranes, as well as the feasibility to be able to use a system that doesn't require solvents or steam or some other things.
Does carbon capture enable fossil fuels?
So I would say when I get asked that question, I like to turn it to the practical standpoint of how do we reach the future that we all want to reach as quickly as possible? Because I think that's what people are really asking when they're asking that question. How do we get through the energy transition and move to a world where we're in a low carbonized, decarbonized state? And so technologies like Ardent's technologies, but other technologies are being built for that future world. But the reality of scaling our technologies to be able to reach it is about decarbonizing the assets that exist now. These are not assets that are going to be retired very easily, right? They are going to exist for another 20 or 30 or 50 years. So when I ask that question, and yes, they're being fed with fossil fuels. So when I look at those systems, I say, what is the solution we're going to deliver that really reduces the amount of CO2 that's going to be emitted over the next 20 years on today's infrastructure, because today's infrastructure is the infrastructure we have now, and how does that enable us to have a scaled up, cost-effective, valuable solution for customers in the 10 to 15 to 20-year horizon, because we've built a business and we've built a solution and we've built everything for the world to come. So I look at it as addressing both. And if we just wait for that future world, we won't arrive at that destination. Mm-hmm. So we all need to build solutions that bolt on to today's ecosystem and anticipate that ecosystem of the future. And when you look at solutions that are better economically, better from a emissions profile, they will win. Solar is here now, right? Solar is cost effective. It did that. So many more solutions can address the energy transition as it's moving from one state to another.
Thank you so much for having this discussion with me, Erica. It was a pleasure.